Good evening and welcome back. This is our first webinar of the spring series. Tonight we're going to be talking about teaching efficiently. Who doesn't want to do that? We're going to look at rates of change from algebra through calculus. My name is Mike Houston and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. Tonight I'm excited to be joined by our two panelists, Tracy Watson and Corey Bobby. Tracy has been a teacher at the high school and college levels for over 20 years. She is currently working as a mathematics specialist at the Arkansas School for Mathematics, Sciences, and the Arts, focusing on AP statistics support for teachers across the state of Arkansas. She was introduced to the graphing calculator as a teaching assistant in graduate school only a couple years ago, and she hasn't turned back. As a T-Cube National Instructor, she enjoys sharing with teachers across the country the appropriate use of technology in the classroom. Tracy, it's great to have you with us tonight.
Thanks, Mike.
And Minister Bobby has worked as a teacher and curriculum specialist for over 20 years. He has taught a range of math classes both in person and virtually at the high school and college levels in Arkansas. He has served as an AP calculus reader for 8 years and has been a T-Cube National Instructor since 2001. Being named a PAEMST PAMST awardee in 2017 was one of the highlights of his career, along with performing the marriage ceremony for one of his former students in 2021. So, Mr. Bobby, thanks so much for gracing us with your presence.
Thanks for having me, and looking forward to it.
We're expecting a large crowd, so your audio is muted. Feel free to say questions to Corey or Tracy using the Q&A window on the right side of your screen. We'll also be using that chat window to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Corey, would you mind talking through the agenda for tonight?
Sure. We're going to start by talking about slope and looking at some Algebra Nspire documents on the Nspire, and then maybe how we can simulate it on the 84. Then I'm going to look at a really interesting problem, I think, about connecting rates of change through multiple representations and multiple equations. And then we're going to talk a little bit of calculus, talk about the secant line and graphing derivatives. And finally, we'll wrap up with a couple AP problems, particularly looking at the lens of what's important in terms of rate that we can do in earlier grades.
Awesome. And then be sure to stick around because one lucky winner tonight will automatically receive a TI graphing calculator. So you want to stick around for that drawing at the end. And Tracy, do you mind talking through our expected outcomes?
No, so we're hoping by at the end of the night, you'll be able to say these things. I can explore rate of change using numbers, tables, graphs, and equations. We hope you'll be able to say, I can investigate and model applications of rate of change using the TI technology. And I can enhance student understanding of rate of change at various levels. So that's what we're hoping you're going to leave tonight with.
Thanks, Tracy. All right, let me kick things off and pass things over to Corey.
Okay, I will share my screen, and I'm going to quickly just say that I know that Mike said, or I don't know if Mike said this or not, but Tracy and I actually are married. I don't know if that comes out, if that came out from his conversation, but so she kept her last name, which if you are familiar with having an unusual last name, it's probably like Bobby. Bobby is my last name. It's pronounced like the first name, but it's spelled wrong. It's a complete disaster. So she wouldn't take my last name even if I forced her to. But we are married, so if we say or do something that's mean to one another, it's okay because we're used to it. I do want you to use chat. I have a friend who loves these. What is your mood tonight? And I would like you in chat to tell me, pick the corgi that represents how you are feeling right now at the start of the second semester. So pick your favorite, pick the corgi of how you feel. I see a 7, a 5. We would actually, if this were a data statistics session, we would probably graph these and all, but we would like to see what corgi you are. Michael's laughing at me.
3s and 8s.
3s and 8s, lots of 3s and 8s.
5's a popular one. There's a 4. Now, the reason we like this one,
the reason we like this is because this is our corgi.
We do have a corgi.
So this is our corgi Blue. She's right at Tracy's feet. So
interesting. I'm not. Yes. What about you? What do you pick?
Oh, what am I picking? I'm probably I don't know, maybe a 2.
I'm number 1.
You're number.
So I'm feeling woo. Let's go.
All right. So that was our little fun activity for the heck of it. It doesn't hurt anything to have a little bit of fun every once in a while. So what I want to do tonight with y'all is Tracy was really. We're married. We've been calculus teachers. We're both calculus teachers, but she's really moved to the world of statistics more in the last few years. And I've stayed in calculus. We both have graded AP calculus, but we are kind of gone our separate ways a little more that way. So I'm going to
bringing us together again.
Bring us back together again. So I want to experience slope with my students. And if I'm and I have not just a calculus teacher, I've taught everything from algebra, geometry, all the way through AP calculus. So I want my kids at all levels to understand slope. All right. So we have some great documents on Math-Nspire. This is an activity called Understanding Slope from Math-Nspire. And what I can do is I can move these points around the screen and it will simplify, or it will look at the slope of this line. So I have I want kids to, what do I want kids to get out of this? What would you want your students to understand by using this, Tracy? What do you think?
One of the things I like about this document is how when they do their slope, they state vertical change over horizontal change. And so it's not just delta y over delta x. It's very verbal about what it is. And the color matching is really helpful so they can see what they should be looking at. And so I want them to make the connections of at your state that you're right now, where does that 5 and 17 come from in the picture?
Are you not seeing my screen, Michael? Are you seeing my share? You're good here? Okay, all right. Somebody in chat said they were not able to see it. So I'm sorry. Okay, all right. I just wanted to pause because if I was not sharing my screen, it's a very common thing. Okay. So I'm sorry. All right, never mind. All right.
So that's like one of the first things that I like. And I like when they do the vertical change, that is a negative vertical change, how it's putting the -5. And can you take that B and make the horizontal change also negative?
So if I go over here, yeah, look, we actually have negative and negative. If I move the rise and the run are relatively from A to B. Now that's from A to B. It's going from A to B. This document can be downloaded from Math-Nspire. Michael's actually going to it's in the it's going to be one of the files that's attached at the end. It's called a TNS file that you can upload to your Nspire and do. Now, if you have students having their own devices, you can blast it out if you have Navigator, or link it out if you have to through the daisy chain. Okay. Michael, you're going to send out the document. Thank you. There's a great question. What do they say when it's vertical? Thank you. Michael will send this document out if you don't have it, but it's from mathinspire.com, or if you search Math-Nspire, it'll come up. But thank you for that question. What happens when it's vertical? It gives us the vertical change over the horizontal change, which is undefined. Very nice. Thank you for that question. Okay.
And this, if you think about it, when you're pushing students to ask questions, if they have this in their hand, they're investigating it. And if you don't have it in their hand, even just them asking you, just like we did, and responding, well, let's go look. Boom. It actually reacts like to answer their own question.
So it's a great, okay. So now that's
Good transition.
thank you. And I wanted to, this session is supposed to be and will be, um, we love the Nspire, but we also love the 84. We are bilingual in terms of TI world. Okay. So there are ways to do this where you can enforce the issue, but I would like to actually look at an analogous way of doing something. Now it's not quite the same, but how would I get students to have a movable line on a TI-84? So April asked, how do I do this on the 84? Everything's a little different from one platform to the other. So I've thought of two ways to get an interactive line that you can explore and manipulate and see how as you change things. Okay. Now it's not going to be the same thing, but the first way that I thought was to do stat and then over to calc. Now this is where you would do regressions. Now regressions you would normally do on like data on L1 and L2. You have data points and run a regression. But if you're not aware, if you scroll down through the regression list,
there's something hidden here that you might not have noticed that Corey's going to take advantage of.
So the next to last option, and I could have pressed the up arrow and wrapped around for the U84 people you're used to using the wraparound feature, but I don't do that when I'm presenting or when I'm teaching students. I always try to take the time to scroll and be the last person to push the button. And if you're following along with me on a handheld tonight, go on with your bad self, okay? But under where the regressions normally are, there is the manual fit MX plus B. So what I can do is I'm going to make it. Now what this was meant to do is like old school, literally drawing a line over a set of data. Like if I were to graph the data, I would slap back in the olden days, I'd plot a bunch of data, I'd slap a meter stick on the board and draw a line through and say, I think that's my first guess. Well, that's what this tool is meant to do, but I'm not going to use it for that.
No, he's
okay.
Going to use it different.
So I want to store the equation in Y1 that I'm done. And that's really just a function of if I were going to come up with a model. Okay. But now in the meantime, I don't want to actually store it. I just want to drop 2 points. So I can drop a point at 0, 0. And then I'm going to go drop a second point. I'm going to arrow over somewhere to wherever makes me feel pretty. And I'm going to drop a second point. And what it's done is it's made a line for me through the 2 points that I made. But I can now change that number. I can change this number, the slope number, to 2. I can change that slope number to 2.5. And I can keep changing that number to change the slope. I could change it to 0.2. And so on. And I can also arrow over and change the y-intercept.
But if you're just investigating slope, the idea is to get them to try different numbers for M and see what it does to the picture, the rising and the falling of the line. So they're investigating that. Now, one thing I probably might turn on here is the grid lines in the background too, because that way they can really make that connection, I think, with a slope of -2 and actually use the grid lines.
I would have to do that beforehand. But I could go here under second format. If you're not familiar, there is on the 84 plus CE, there are grid lines.
This is really nice.
That would allow you to then do the rise over run counting a little easier. It works much nicer on the 84 CE than on the prior versions, the black and whites. Yeah. But now I've lost my interactivity.
Yeah.
Okay, that manual fit would let me play around with the numbers, so I would have turned the grid lines on first. My bad. Okay, so that's one way to get an interactive line. Do you like that? Okay, April, do you like that? Because I'm talking just to you now, and I hope it's April because so all right, that's one way of doing it. The other way of doing it, and if you notice, once I'm done, the equation was stored in Y1. Okay, the other way, and probably the better way, is to use transformation graphing. So I would go down. The only problem with transformation graphing is that it uses A, B, C, and D as the parameters. When I choose transformation graphing from the app, nothing seems to have happened. But when I look at Y equals, now notice in the upper right, it says quit app, and it even tells me transformation graphing. They have greatly improved transformation graphing on the CE, in my opinion. And so what I can do now is, but I have to use A, B, C, or D as the parameters. So I have to use alpha A. This might confuse your algebra students. AX plus alpha B. I might do both just to see. But now I'm going to get an equation AX plus B where I can change the values of A and B. Now it's not the same where I'm dragging the points, but I actually have better control of the values than by dragging the points. Okay. So now when I graph it, I can change. What equation am I looking at right now? Can you tell me in chat what is the equation that we are looking at? The equation of the graph we're looking at right now? Okay, yes, it's a slope-intercept form, but what?
And so what specifically y equals,
y,
there we go.
There we go. Now they're coming in. Thank you. I guess I wasn't
1.
X plus 1. Or maybe I would be more explicit and say y equals 1x plus 1 because I've put in A is 1 and B is 1. Now I know that we often don't do that, but it doesn't hurt to really stress that, I think. When you're talking,
especially when you're talking about slope here.
Especially when you're talking about slope. I don't think it's bad to say 1x plus 1. All right, and that's just me. You can call me bad names later.
Now, how do I change the values?
So right now, if I change the value of A to 2 or 3, the value of A changes, and I'm going to go down to change the value of B to 0 because my parent function really should be y equals x. And one of the nice things, we don't even talk about parent functions. I can actually do true transformations, or I can have a parent function going on here. So that black graph is my parent function.
Nice.
And the blue function is my transformation. Okay, so I wanted this, I am very in tune with both platforms, but this session, we're going to really try to focus on the math, but I am going to try to
jump back and forth
between the two platforms. So I hope that doesn't bother anyone or bothers everyone. Either way, y'all can tell me.
We're going to try and make sure we do enough on each so you can do it on whichever one you're doing. So.
Okay. So how do you feel about, I feel like it's really important for kids to spend a lot of time getting the ideas here. And if we put 0 in, we should get a horizontal line. If we put -2 in here, I think it's important for students to understand and experience. That's the key word. They should experience slope in many forms. But I actually don't think it should be symbolic and graphical. I think it should begin numerically. Okay. My personal opinion is that of the multiple representations, numerical representations make sense to most of our students. I think equations and graphs are harder for kids than numbers and tables. All right. So I like to see, I like that there's a way for kids. Oh, and you also can look at the table. Thank you. Yes, I could add the table in here. And I'm going to do something, Tracy. I can't believe Tracy didn't yell at me to do this. Not to do it. If you go into the mode here, you can do a split screen where I do a graph table. It's much nicer because the resolution is higher. I can do the graph table and see the changes in the value. So if I were to go back here and make this value A3, all of my table updates so I can see it numerically and graphically. And if I can mentally substitute those numbers in, I can see it symbolic. So here we have 3 representations on the screen at the same time. Well, kind of 2.5 because I have to mentally put those numbers in for A and B. All right. So thank you for that. I like the confirmations in the chat.
And yeah, that's in the CE that does that split screen
here. Yeah, the split screen is much nicer in the CE. There, you were able to split it in the older calculators, but it was really a resolution issue that became not so nice. Okay. All right. So this is my my beginning. Was talking about slope, but I'd like to talk about this problem. This is a problem from a friend of mine, or I guess he serves on one of the local math teacher organizations in Arkansas. He's one of the board members, and he's a really good guy. His name's Dr. James Federley. He's at the University of Central Arkansas, and he did this problem with us a couple months ago, and I've adapted it to meet our needs tonight. It's from an old problem from Connected Math Project. And so the first situation, the split screen was under mode. If you want to go back to the 84, thank you for asking that. It was mode, and then when you go down
to
full horizontal, I could split it
table.
horizontal, but Tracy loves the graph table split. Okay, that's how I did the split. Okay, so this problem is a pretty old school problem. They did Miss Chang's class did a walkathon. They collected $144, and they were going to buy books for children in a hospital. Okay, they wanted to spend $12 worth of books each week, and they make a table. So what I'd like you to do is take a moment, and Tracy's going to do this for us too, and she's going to make a table for the situation, and she's basically filling the role of Isabella, and you can too. Please take a moment and make a table.
Okay, so I'm going to talk myself through a little bit. I'm starting with $144, and then remind myself each week I'm taking out $12 to buy new books. So I'm going to keep track of the number of weeks that go by and see if I can subtract 12. Okay.
Oh my gosh, she's so slow.
Leave me alone.
So we're doing N and the dollars here.
Mm-hmm.
So 0,
144.
Oops, I lost my annotation. I'm used to annotating on Zoom a lot. So she's making a table here for me. Can y'all see us in the window? Okay, can you see us if she were to hold that up? Put it up close. Fill up the screen there. Y'all agree with that table?
Yeah, you can see it.
Is that okay?
So I've got my table done.
Okay, so she's made a table. What do you want? Nspire 84. Who goes first? 84, 80, Nspire. Because I'm going to do one problem on one, and I'm going to do it on
we'll switch.
And we'll switch.
84 was first.
I saw an 84 first.
Phyllis almost made it.
Yeah, you almost made it. Okay, I promise those of you who were Nspire will get this on the next one. Okay, so what I want to do is we're going to make a table. Now, if you are an Nspire person, you can do the whole problem on whichever platform you like. I'm going to do them on both just to show you. So I'm going to make a replica of her table. So it would be 0, 1, 2, 3, 4, and so on. Okay.
That's close enough.
All right. And then I'm going to go over and I'm going to put in the numbers, and her numbers were 144. Oops. How about I do it right? And then 132. I should be able to subtract 12, but it's been a long day. 120.
118.
No, or 108.
108. Can't read my writing.
108. And then 96. Y'all were
84. 72.
All right, and we could continue. All right. It should go down to 12 or something, right? And it goes down to 0
till we're out of money.
Till we're out of money. But right now I've got enough. I could continue, okay? But what I want to do is I want to look at the difference in each piece. Now, what did Tracy actually do each time? Now, I know kids should know this and we should be able to do, but the lists went down by 12 each time. So I want to show you a little feature that's kind of nice that I can do in L3. If I go over here, it's under list, second stat, and then ops. The operations on a list, there's a command that I really love called delta list.
I did not know this until he showed it to me, I'm embarrassed to say.
Okay.
I may have used it ages ago, but it's been a long time.
Yeah, and I knew this was in there, but this delta list is going to take the difference in the list that I choose it to. So term by term. So if I do delta list, and I'm sorry, I should have said this. I did it, but I didn't say it. I'm on the column heading for L3. Okay, I'm on the column heading for L3. and then I chose that delta list command. Am I okay? Do I need to like back up? Did I lose anybody? And what delta list am I interested in? What list am I looking at is I'm interested in looking at the difference in the terms in L2. Okay. So I am looking at the difference and term by term by term in L2.
I feel really good that I did good arithmetic since I got -12 each time. I'm confirming that I did good numbers.
Yes, and
if a student would see something, one of them different, it would get them to think, whoa, what happened?
It should have come out to be. Now, why did I get what I got there? Can somebody tell me why? Well, I'm not going to do delta L. I never did do.
I'm gonna say I think you can.
I think I could
Go
do.
try it, Sarah, and let us know.
Yeah. Well, delta L1 would just be 1. So you'd always
Right.
be dividing by 1.
Yeah, but
Yeah,
I don't think it'll give you an error message.
No, I don't think it'll give you. It should let you do a calculation there. Yeah, I don't see why it wouldn't. I've not tried that, but that would allow you. Now, why don't I need that is because I set this problem up so that L1 is incrementing by 1. Sarah, you're actually thinking way ahead of me, and I love what you're thinking because I want the independent variable to be starting with steps of 1 so they can see the slope. Those -12s are the rate of change. Now, I also have another question for you. What does the -12 represent? Can anybody interpret the -12 for me that we're seeing?
Oh, you're using the scary word interpret.
Interpret it in terms of the context of this problem. Here, remember the problem here. What does the -12 tell us? I'm real good at waiting. I'll just sit here and look stupid for half an hour until somebody tells me what the -12 means. I'm really good at looking stupid. Okay? It is the slope, but I want an interpretation. Interpretation needs to talk about units. How much money is taking out? It's the rate of change of money per week. We're spending $12 to buy books each week. It's dollars per week. Okay? Units are important in rate. It's not rate of change is not you need this, and this is going to lead to calculus. When you're teaching rate of change, please bring the units in there. It's the change in money, or it's the spending $12 each week, or the amount in the bank is decreasing by 12 each week.
So having those two units, your slope change in vertical over change in horizontal, having both of those units is really important when they're expressing this kind of value. It's
shows up on the AP exam. Okay. And this is something that I think an 8th grader can and should understand. Okay. All right. So let me go back to the calculator. I can then, of course, graph this, right? So I could go to second stat plot and turn it on. And I'm going to do a scatter plot. I've got it set up for L1 and L2. And then I'm going to do a zoom 9. And I'm taking way too long here. Okay, and I'm still set up. Oh, I got my graph table thing going. And and now I can still find my, I can find my equation by doing -12.
We have transformation graph.
That thing's still turned on. And then the y-intercept should be 144. What a happy little accident.
Oh, sweet.
I did not mean for it to happen that way. Give me.
Right.
Am I the only one who's impressed that I meant that? I didn't mean that for that. Hey, nice to when your calculator is left in a mode that you didn't mean for. I mean,
it's all, and it shows you it's all connected.
Yeah.
How this stuff really just connects together. That's fantastic.
Yeah, I did not mean for that. I honestly did not mean for that to happen.
Move on.
All right. So what we've got.
Celebrate later.
Yeah. All right. So this is what we did. We did the table, and I didn't capture my screen with a delta list. And then I did a graph, and these slides will be shared with you as well. But I love building the equation this way. I really encourage you to start with the week and the value, and then look at the subtractions, and you can see the repeated subtraction of 12, and it builds you to the formula. Okay. So I am seeing it be linear. Cool. Y'all, and I'm
Negative slope.
negative slope, and
Yeah.
the interpretation isn't a big deal. Okay, so I know I'm going really too slow. I gotta go. She wants me to go faster. Second situation. Now I'm gonna do the next one, the Nspire. But what I want you to do is same setup. They got $144, but this time they take $2 for the first week, $4 for the second week, $6 the third week, $8 the next week, and so on. It goes up 2 more each week. It's a little harder. Make your table. Take a moment.
$8. Okay, I kept up with you on my arithmetic is pretty good right now. I kept up with you. $8, then it's
And then
$10.
and then $12, and then yeah, 2 more each time. I'm going to switch to the Nspire, but those of you, so what I'm going to do is now I'm going to do it in a list and spreadsheet, and I'm going to have 0, 1, 2, 3, 4, 5, and 6. Okay. And I could go to more, but I think she did up to 7. Okay. Now I'm going to, and again, this is the way. Now, what I want to do here.
Title columns. Title columns.
Oh, yeah, I could.
Nspire.
Yes, I got to say this is money, and this would be weeks, right? Sorry, I forgot to put my headers in there. Okay, and then I'm going to do 144. That's where we started. We take 2 away, we 142. If we take 4 away, it'd be 138. And then if we take 6 away, it would be 132. Taking 8 away would be 124. You guys check me if I'm wrong. Then we would take 10 away, 14. We take 12 away. Next would be 102. And then finally, we would take 14 away, which would be 88. Do y'all agree with my numbers there?
We will find out.
We will find out. Okay. Now, how would I do the delta list on the 80 or the Nspire? I can literally, this is Excel. So I can say equal, let's see, B2 minus B1. I'm treating it like a spreadsheet. And I actually, in some ways, really love this because the most underutilized resource in the math classroom is the spreadsheet. So I can, where's the fill down? Is menu, actions, fill down? No, it's
data, I think.
Data, fill, and then I can arrow down. Can't I?
Yeah.
I don't want to go to the last one. I want to go to the next last one.
Why don't you want to go to the last one?
Because it updates, spreadsheets automatically update, and I can't, there's no data down here. When you're doing the delta list or doing this, there's nothing after your last one to do away. Okay. So if you're an Nspire user, okay, you set up a formula, okay, like a spreadsheet. So I typed in B1 equals B1 minus B2. The way that you do the fill command on an 84, like, or an the Nspire, on Excel or Google Sheets, I grab the corner and I drag it down, right? But it's menu, data, fill. And that first, I need to be on the first one. And then if you notice, as I drag down that little dotted line, it's going to drag the formula down and update it just like it would be in Excel.
And as soon as you hit enter, then it pops all those values.
And if I look at the formula, I did not type this, but in this C2 situation, it took B3 minus B2. If you've never used fill down on Excel, it's a beautiful thing. And you should learn how to use that because it's fill down is a command, is a beautiful thing in terms of spreadsheets, but it's available on the Nspire. And I can see that Tracy was correct with her math. But what's different here? This is the rate again, okay? I'm going to call it rock because it's the rate of change. Because Tracy rocks.
Okay. Yeah.
Can you interpret what's going on with the rate of change here? It's still value per week, right?
But it's changing. First it's -2, and then it's -4. Oh, it's not a constant rate of change.
Okay. And I do think it's not a constant rate of change. Thank you. It varies. The rate of change is varying linearly. And I think an 8th grader, 9th grader can handle this. We never, ever do any rate of change except constant rate of change. We can introduce, and if that second difference, yes, we could do the second difference, we could do the difference of the difference, and that means it's what? What kind of model do we actually have here? It's quadratic. Okay.
It's anticipating that.
But I want, if I look at it numerically, they can follow it and they can, then it can build and make sense. So when I go to the second situation in the table, there are my differences. I captured my screens on the 84, but it doesn't really matter. There's the graph. You as math people understand, oh, this is going to be quadratic. But if I look at it, the kids can see here, I'm taking away 2, I'm taking away 4, I'm taking away 2, 4, 6, 2, 4, 6, 8. And then as I go here, this column, it's 2 times 1, 3 times 2, 4 times 3. It really ends up being n plus 1 times n. It's whatever week times n plus 1 a week. And that's what I'm taking away. If we simplify it, we get the quadratic expression.
And so depending what level you're teaching, I mean, we're taking this just from looking at the list numerically, and then when they're ready, looking at it graphically, and then looking at it table-wise with that extension to get to that equation, okay? And there is a delta list.
There is a delta list. Thank you. Thank you, Beth. Yes, there is. I just love the spreadsheet approach better personally. I feel like that teaching, anytime I can teach a kid about a spreadsheet, I'm all over it. But Beth, you're absolutely right. Thank you.
Yeah.
Okay. All right. So I have a third one, and I'm going to let you pick the platform that you wish. Okay. This time, the numbers are $1 the first week, $2 the second week, $4 the third week, and then $8. It doubles each time. So take a moment and make your table. Tracy's making her table right now. What platform should I do it on? Any care? Phyllis is 84. All right, we'll go back. So let me get to my 84 here. Stat and then edit. I'm going to clear out L2. And so I did 144. I can keep the first list, I think. 143. And again, it doesn't matter. You can go either way. What's the next one? 141. That was taking away 2. Then I'm going to take away 4, which 137. And then I'm going to take away 8, which would
129.
129. All right, y'all help me out with these numbers. And
113.
113.
And 81.
And then 81. Okay.
Holding my breath that I did that right.
All right. So what we're looking for is doubling numbers, and I'm going to go back and I got to recompute. Now, if I'd have done the locking feature that Tracy likes, it would have updated manually for me. I probably should have done that. But I can do data. Oops, I'm not in the list. Yeah, I'm in the wrong spot. Sorry.
Got to be on the top.
Got to be in the top of the list.
The name of the list, because you're doing an entire list operation.
I'm going to erase it.
Makes sense.
And I actually, is it putting it in quotes, right?
That keeps it.
Yeah, if I would have done this, this is Tracy's, it's alpha plus. And then I could go to second list, ops, and then do the delta list L2. If I would have done this, then it would have automatically updated.
It's kind of like locking in a formula. You see, there's a little lock up there now at L3, having those little quotes on the 84.
And you enter each calculation in the entry line at the bottom. I think you have to you have to do it on the header. But now if I were to change something, it would update. So like if for some reason I got this one wrong, if I go over here and got the 81 wrong and we put 91 here, this is what Tracy was talking about earlier. It when you use that quote, it automatically updates for you. Okay. So that lock, when you put the formula in quotes, it locks that formula in place and then it automatically updates as you correct things. Okay.
So if you notice at the bottom now, we're seeing exactly what we asked it to do. If you don't put the quotes first, which is alpha plus, then it does the operation but doesn't keep that formula. So it's a way to lock the formula in.
And it updates, it would have updated if I'd have done that the first time. So this one should have been 81. Okay. Now, what is the rate of change in this situation?
Okay.
What's the relationship in the rate of change? It's exponential. We were doing an exponential difference and we're getting, or we're doing an exponential relationship, but we're getting an exponential rate of change. Now I'm going way faster than I would with an algebra kid, but a kid can see the pattern here at much, much younger age. And their experience, I want to encourage you to interpret rate of change in terms of the units, the y values divided by the x values, whatever they may be. In this case, they're dollars per week. And I want you to play with the rate of change. It's possible to have a rate of change that's not constant. Okay. I think this is, so that's what I'm saying here. And I could have had more of these. The graph is exponential, and all I'm doing is letting them see the pattern. Now, but they can actually, and depending, maybe I'm in at the end of Algebra 1 or in Algebra 2 now. I'm not sure where you might be teaching this depending on the age of the kids and what you're teaching. But I do think that younger kids can even do it numerically and see the rate of change. So, go ahead. You were going to say something?
I was just thinking, so that's the thing. We're trying to get them to, when they hit calculus, that this is not unusual. It seems like now when we talk about slope, it's constant slope. They think that. And then we're fighting the battle in calculus. No, it doesn't have to be. So kind of giving us that reminder, I think, is important. The quotes are found under alpha plus.
Yes.
You look at the green stuff on your calculator.
So, like, yeah, if we go over to if we wanted to do, you got it? Yeah. That formula, that's a way to lock it. But now what you actually have to clear it twice, because I have to clear, enter, and then I have to delete that formula out of there. And then enter to erase the lock. I have to erase the lock. You need to know this if you're going to do that. And then I have to go to the list header again and hit clear and enter to erase the data.
So it's a step
removal.
Yeah, stuff.
But the nice thing is it makes your lists, when you use the quotes, it makes your list operations or your list formulas dynamic, so that when you change the original value, the resulting value is updated. You see how I didn't have it update initially? If with those quotes there, it would have updated immediately. Okay?
Okay, now let's get into some calculus.
All right, let's do a little bit of 15 minutes. Oh, gosh. I've had way too much time on that problem. All right, so I want to do a quick secant line approaching a tangent line. There are math-inspired documents that do this. And I'm not going to spend a ton of time on this, but if I go to the Nspire and I do it here, I'm going to make a new document. So we can start with a graph. I'm going to do a simple equation. I love exponential functions. Maybe that's my curse, but whatever. So I'm going to, and with the Nspire, you can literally just grab the screen and move it. What I want to do is I'm going to mark a point. Now I'm going to just build it in the, like I said, in Math-Inspired, there are some that are already pre-built. So I'm going to do the trace. Everything lives under the menu. So I'm going to go down to trace. And I'm going to just trace on this graph. And I want to go to a nice convenient point. I can trace, but I can also just jump, just like on the 84. So I'm going to jump to 1, 2. And if I press enter, it marks that point. Okay? And then I can go to geometry and do point on. So I'm going to throw another point on this graph, and I'm going to put it right there at 3.7, because that's exactly where I wanted it. All right. And I can make the line between these two. So I can actually walk, and I have walked my students through building this themselves. All right. There's something about building this that helps, I think, students understand when you're teaching or introducing them to calculus. So I would go to geometry and I want to make a line between those two. So I'm going to go to geometry, points and line, choose line. And then I'm going to click the point at 3.17 and the point at 1 and connect them. And I have now made the line between them. That's the secant line. And then I can measure the slope of that line. And if I click on that line, it tells me that slope is 3.21. I'm sorry, 3.23. So I have built the secant line, and what I can do is now just drag that point closer and closer to 1 and see what happens to the slope. And as I get closer and closer, that slope value gets closer to the, I'm going to put the slope
Yeah,
here.
you can grab the slope.
I can move the slope a little bit there. So if I move the points closer, I can see the slope getting closer to the actual value. I could actually make this value as close as I want, as I want. And then I can see the slope, which, well, I moved it away.
I'd probably grab the slope and
Yeah,
put it way over on the side.
I would have broken the slope off to the side. Okay. So there's how you can build it themselves and having them actually, this is always the hardest thing for me in the world to try to draw. I was a terrible artist. I would try to draw and the kids would laugh at me. Okay. You can simulate this on the 84 by, and I'm going to get off of Tracy's graph table screen.
And while he's doing that, think about what we're doing. We're watching a changing slope, a changing rate of change when we're looking at that slope. So we're making those connections from the slope doesn't always stay the same, it changes.
So I'll turn her grid off. All right, so I'm going to go back to this screen and turn off the plot here. I want to do 2 to the x.
Clear your y3.
And I want to clear my y3. All right. So I want to have a point at, right? So when there's my graph, oh, let me get zoom standard here. And maybe I don't need the negatives, do I? So I'm going to make this like -1 here. All right, so I have a decent graph of the exponential here. I want an equation that goes through the point 1, 2 and the point 1 plus a, comma, f of 1 plus a, all right? So, or y1 of. So this is these are the 2 points that I want, okay? And I'm going to figure out the slope of that. So when we go into here, if I go down, I need to do the slope, which would be alpha. Oh, by the way, 84 folks, alpha x makes you do the fractions really quickly. So I can do alpha trace y1 of 1 plus a. And I know that we don't want to use h. We'd actually prefer to use h, but I have to. Mm-hmm. The y value would be 2. And then I'm going to do 1 plus a minus 1. That's the slope. All right. And then that would be times x minus 1. And then I'm going to have to add 2. It would actually be y plus 2 or y minus 2 on the other side, but I'm going to add the plus 2 here.
And so what he's done is he's in y2 wrote the equation for the secant line that we're looking at, which is movable.
Now it's movable. It's going through the point 1, 2 on the function, and I don't want it to, let's make it the a value of 2. So now it's going through 1, 2, and 3, 8. And then I can make it be 1. And I'm making it now go through 1, 2, and 2, 4. And now I want to make it 0.5. This is actually really nice because I'm controlling the delta x in the secant line.
So we're doing what we did on the Nspire on the 84, just again differently, okay, because it's a different device.
So I wanted you to see that you can get that interactivity using the 84. Okay. Mm-hmm. Yes, I would be showing this in smart. Well, now these kids, I mean, they Zoom. They'd be watching me on Zoom now because I teach online. But if they wanted to keep up, they could type. We're talking about at this point. I'm talking about calculus students, so they are. And I would have had this all written out. We would have worked this all out. I'm going much faster because I only have 10 minutes left with you. But I wanted you, if you want to talk with me afterwards, I can help you through this, and you can holler at me, and we'll figure out how to make it happen.
Because at this point, hopefully, the teachers before you, if you're teaching calculus, the teachers have used the 84. And so some of this, you're just really tweaking what they've done, and stepping it up with the math part of it.
So I'm not going to do, I was going to talk about graphing derivatives, graphing a function that's derivative, but I think I'm running out of time. I want to turn it back over to Mike, but I want to pay. So, well, I'll just show you what I had in mind because you can graph a function and you can graph its derivative using the derivative notation, and it's the same on either platform using the derivative command. You would just say the derivative of y1 and it would graph it. So you can look at, and this is important to look at, the relationship between max and mins and zeros of the derivative.
Question about why we used a plus 1 and not just a.
Because I started with the point at 1, 0.
1, 2.
1, 2. My x value was 1, and I wanted to move a little different from point 1. Okay?
Yeah. And so when you do the slope, the bottom denominator could have just been 1.
Yeah.
But you're doing the difference in your, you're doing it from the point 1, 2.
Because the number I picked, the point that I picked was 1, 2. That's why I was doing 1 plus a.
Yeah.
Or a plus 1. So.
Okay.
All right, so I'm not going to do this in the interest of time. You may have done this. If not, it's really easy to do. You just type in the function, and then in the second equation, you type the derivative.
And both devices are identical.
Pretty much identical using the templates, okay? So I want to look at a couple AP problems. I think there's a typo in the identification of problem. This past year, this was the question that I graded. And I think I graded, I don't know if any of y'all are graders or readers, but this is the question that I graded this year, and I graded one question for 7 straight days and I did overtime. I did like 60 hours. I have never done one thing for 60 something hours. This question was, now if you notice the X values or the independent values are the centimeters, and then the function values are milligrams per square centimeter. It's about the density of a petri dish. And they wanted you to estimate f prime of 2.25 and correct units. Interpret. This is what I'm talking about, okay? Interpret the meaning. And at 2.25, so we're looking at, the students had to look at these 2 points, okay? They had to do 10 minus 6 over, 2.5. This is minus 2. This is a little bit harder. So they would have got, I'm so used to Zoom now. This would have been 4 over 0.5. Now that would have gotten them 1 point. The interpretation is a little bit more, is milligrams per centimeter cubed, or milligrams per square centimeter per centimeter. All right. So if I scroll down to the answer, there's 2 points to this. And I want you to notice if they had left it here and not done 8, that would have been fine. They don't have to simplify the value, okay? But if they did simplify, they better do it right, because if they simplified it wrong, and lots of them did, they got it wrong. But the second point, there's a point for them interpreting, and there's 3 things. They have to have at 2.25 centimeters, they have to tell me what it is in relation to the X values, that it is increasing or decreasing, and they have to have the correct units. And Michaela, or Mike, I'm not sure how to say it, has the right units in chat. Okay, they are looking all 3 things. Any one of those 3 things wrong, they lose the second point. Any arithmetic points, they lose the first point. So this is all algebra.
Mm-hmm.
Okay. Now the interpretation is a little bit more based in calculus. I get, it's a little more advanced than that, but it's really just algebra. And a big part of that is talking about the units and the interpretation. Okay. There's almost always a question on the AP exam that is interpreting from a table, which is what I did for 30 minutes earlier.
Yeah.
Okay.
And Sarah, yes, if they did an incorrect arithmetic and lost the first point, if they use that answer on the interpretation correctly, they can still earn that second point. They don't like double dinging students.
So I would encourage you, is this not something that I could model and adapt at an algebra level and have kids do? I mean, I wouldn't use the prime notation, but that would be how I would try to write some of my questions that had them do the calculation and the interpretation from a table, because there's always one of these.
Yeah, I mean, it's a table, and if I probably didn't use tables enough when I taught Algebra 2. I liked algebraic and graphing. I didn't do tables very much.
No.
And so I hurt my kids because they weren't as comfortable with tables as they should have been.
Yeah, we definitely, it seems like as a calculus teacher, it was one thing that my students did struggle with, and it's really quite simple. I mean, I was able to get them over the hump and teach them, but it's something that they can have more experience. That's why I loved the book fund of the walkathon problem, because I was able to do the tables, and I was like, oh my gosh, I should be doing this in my algebra class, so that they are more prepared for calculus. And that's what I want. I don't want you to become an AP reader unless you are a calculus teacher who's interested in being an AP reader. But I think it's important for you to see that. Okay. And then this one, I think I had.
This is the one that the handout may say AB4,
yeah,
but it's actually question 3 from the 2017 test.
So. April, you're right. It does seem, but if you notice, that table did have decimal numbers in it, and it was okay. I want them to see that, or fractions. Please leave it as a fraction.
Yeah.
And I want to look at parts B and C, and I think Monique talked about
1 minute.
Okay. Oh, I'm sorry.
Because Mike wants to.
Yeah.
Shut us.
So, increase and decrease. There are a couple, there's an interpretation. We can talk, if you wanted to look at this, you can, but there's the interpretation of intervals of dust increase. And what about the slope? They're just reading the slant of the line off the graph, but they're looking at the derivative of the derivative, the slope of a slope, which is kind of fun. So, all right, I'm sorry I went long, but Michael, you're all good to go.
Thanks so much, Corey and Tracy. We're going to begin wrapping things up for tonight. If you have any last-minute questions for Corey or Tracy, please try to get those asked. I know they'll do their best to get those questions answered. To receive a certificate of attendance, go ahead and click the link in the chat window. And also, this is a link for the documents as well. Many of you have asked about those documents. And if these links aren't working for any reason tonight, just hang tight. You'll automatically get a follow-up email within a couple of days, and that email will contain a link to the recording, so you can go back through at your own pace, a link for the certificate, and a link for the documents. And if you are watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. I almost forgot our webinar giveaway. So our one lucky winner tonight, who's going to be receiving a TI graphing calculator of their choice, is Chris Brewer. So Chris, congratulations. We'll be in touch over email in the coming days here to give you some more information about that and to hear about what selection you choose. But congratulations, Chris. If you're in need of a post-webinar follow-up once we leave the webinar tonight, feel free to give us a call or send us an email. We'd love to hear from you. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we hope you will share your thoughts in the post-webinar survey. Huge thanks to Corey and Tracy for everything they put together tonight. Thanks so much, guys. And thanks everyone for joining us. We hope to see you back online next week. Have a great night, and go Steelers.